Luckily for you, today's an algebra review.
Oh no. Oh no.
Go ahead and get out a piece of paper.
Algebra scary.
Is the internet back working? Those of you who live around here?
Oh, yeah.
Okay.
It was working.
Okay.
Parent-teacher conferences in 2 weeks. I can't wait that long.
We will only be meeting with kids that we deem that they need to be met with
Oh.
because of COVID, so we can't meet with every parent. So.
Oh, I thought they were doing everything. Oh well.
We will. I mean, normally we would, but because of COVID, we're not going to do that. All right. So this chapter, you will see very infrequently some quadratics. Very infrequently. So they choose to review it now before we get into it. You see a problem like that, and then throughout the book a couple times. I mean, I want to say it's like 5 or 6 times in the entire book that you get a quadratic to get a solve. All right. So what do you guys remember about quadratics?
They're four-sided.
No, but
A
it
quadratic is a
certainly
variable with
applies
a
that
linear
though.
variable and a quadratic variable, meaning there is a exponent variable that is there.
To the power of 2.
Yeah.
Okay. So we get a quadratic is defined as a function or an equation where the value of the x is to the second power, as opposed to what other things have we seen? And what would we call that? You remember from last year? Did you say first or third? First. So what's x to the first power called?
A linear equation.
Okay, so linear equations make lines, right? We literally call them linear equations. They are when x is to the first power, right? Quadratics make?
They make parabolas.
They make parabolas, smiley faces, frowny faces. Concave up, concave down. And they are an equation where the x is to the second power, okay? So we have an independent variable, dependent variable, right? Okay, so that's what we're going to do today. We're going to talk about solving quadratics, which last year we, for Algebra 1, it was probably good enough. I'll just say that in my Algebra 1 class, we never saw a quadratic. It wasn't until Algebra 2 that we saw our first quadratic. Most modern algebra books absolutely expose you to quadratics, Algebra 1, and to solve them. Okay? All right, so to solve quadratics, I usually want to show you a picture of one to explain what it means when you're actually solving it. Now, here's a concave down one.
That means.
And it absolutely, it mirrors or it models the, any object under the influence of another force, gravity, makes parabolas. Okay. So what we're interested in is where does the object start? How high does it go? Where does it land? Now, depending upon what you want your x-axis to be, you could make your x-axis time. If the x-axis is time, and this doesn't represent the path of it, right? It represents the changes in height. But if you want to make your x-axis the distance, well, then this absolutely is 100% the path of the object. So engineers, scientists, whenever they want to model things that are under the influence of gravity, which by the way is everything, right? Even when we say that they're weightless in space, it doesn't truly mean weightless. So it's not really called, it's improperly called weightlessness. It should be called microgravity. Gravity is so small at that point. I mean, the sun is still there. The reason why the Earth is going around the sun is because of gravity. So if you're in space, you are going around the sun, you're under the influence of the sun's gravity. So remember, gravity is a force that both objects exert upon each other. Okay? But we are interested in those 3 points. It's vertex for concave down here or concave up. We're interested in the bottom vertex. That's called a minimum. This is called a maximum from Algebra 1. And we're interested in where it starts and where it finishes if x represents the surface of the Earth. And because these right here, these 2 gray dots right here are on the x-axis, what's the y value right here on both of these gray points?
The answer to the equation.
No, what's the y value on both of those points? The gray one's right here. What's the y value? It's 0. And that's why a lot of books, including your calculator, when you solve a quadratic, it's actually called find the zeros.
Okay.
So like literally when you tell your graphing calculator, You tell me what the solution is to a quadratic. It doesn't say solve it. It says find the zeros. And that's usually not explained very well to most math teachers, but that's what you're finding. So we basically take the equation that is this curve right here. We set it equal to 0, and we see what the x values are. And when you solve, when your calculator tells you the answer, it's telling you what the x value is of where the parabola crosses the x-axis. And where that is, the y value is 0. So when you actually solve a quadratic, right, solving is called either the solutions, it's called the zeros, it's called the roots, because remember, if it's a really simple one, like x squared equals 9, what do you do to both sides? You take the square root, that's why it's called the roots as well, too. Okay? Say again?
No.
All right.
9 equals x? Okay.
Well, take the square root of both sides.
3 equals x. Yeah, 3 equals.
And?
-3.
Yeah, -3 and +3 both satisfy that equation right there. Okay, so that's why it's called zeros, roots, and solutions. So when we have an equation, right, remember linear equations are y equals mx plus b. Quadratics equations are the form of y equals ax squared
Plus
and all, some other
plus
stuff as
bx
well.
plus c.
You got it. So what we do to solve it is step number 1 is we let y equal, we're trying to find these two dots right here, so we let y equals 0 and we solve that equation. So when you're solving it, all you're doing is letting y equals 0 and finding out where does it cross the x-axis. Okay. So we did not have a fault. In fact, we stopped when COVID hit right when we were about to get into this chapter, right? We got a little bit into it. Last year, we saw lots of factoring. Let me back up. Why are we doing this in geometry and not in algebra? Well, because here's what the problem will look like. Not the chapter we're about to do, but in general. What's the area of this rectangle?
30.
So all you do is do what?
10 times 3.
You know, you can't use this. We haven't proven this, but that is true. So what they're going to do in geometry is instead of it being 10 or instead of it being 3, it's going to be an x, right? Oh, by the way, these are both exactly the same.
X squared plus 7, so it's the square root of 7.
Well, so if you multiply these two together, you don't get 30. You get x squared.
X squared plus 7x.
Plus 7x, and that's got to equal something. We know it equals 30. We just don't know that because we don't even know what these two numbers are. So in what we're about to do in this chapter is it is on quadrilaterals, by the way, is they're going to give you quadrilaterals. You're going to have a length, a width. They're going to be variables. When you multiply them together, you're going to get a quadratic that you have to solve. It's not going to happen every single question, but there'll be a few throughout. That's why we're doing this review right now. So, do you guys remember from last year how we solved quadratics?
Yeah.
There were 4 ways.
The negative b plus or minus the square root.
I mean, in general terms. 4 ways to solve a quadratic. Quadratic equation.
Factoring.
Factoring, if it's factorable.
Yeah.
And the other 2 are the ones that.
Graphing, solving merge the graph.
Okay.
And also.
The one that no one will remember, which I do not believe I taught to you, but you got to correct me if I'm wrong. I don't think we got to this because COVID got in the way. There's a 4th way, it's called completing the square. And I may have said on the video, because I know I did quadratic formula, but I probably said was the quadratic formula comes from this process called completing the square, but I am almost certain I didn't teach it to you. So, well, you didn't get to learn it. So you will learn it in Algebra 2, absolutely, and you will use it, depending upon what math courses you take beyond that. Completing the square is always that nasty thing that pops up. The math teacher says, do you remember completing the square? And every kid says, yeah, I remember doing it. I don't remember how to do it. Because everyone remembers factoring and they remember quadratic formula, which is good because those are the 2 techniques we'll look at. So where do we stand on what we learned? Well, do you guys remember how to factor?
Yeah.
What's the answer?
X. Like X.
Do you remember what the question asked to factor?
What are the coefficients?
No. Ben, do you remember? I hear him breathing. So the question says, what 2 numbers multiplied is -8 that add up to +2?
Oh, okay. So then it's going to be -6, 2, and negative.
What 2 numbers multiplied is -8 that add up to +2?
-2 and 4. -2 and 4.
No.
Why not?
-2 and 1. -2 and -1. That gets you a positive.
-2 and +4.
-2 and +4. Yes, that's correct.
That's what I
So
said.
-2 and +4. I heard it backwards. I'm sorry. -2 and +4. Okay. Now it's okay if you don't remember factoring because you're going to get it again in Algebra 2. Do you remember what you did after you get this?
You
Say it again. No, that would get you right back to where you started.
well, it's x squared. No, yeah, that will.
It was something called the zero product property.
Oh yeah, whatever. Oh yeah, one of them multiplied, but one of them cannot be something like that.
Something like
One
that.
of them has to be 0.
Or-
For the equal to be 0.
Or
Or both of them have to be 0.
so you set each one equal to 0 and you solve it.
Mm-hmm.
So what's the final answer?
X equals 2 and -4.
And that's factoring. Okay. Now it's okay if you don't remember it. Most
I get
kids,
it.
when you get to geometry, after especially after the year we had last year, are not going to remember this. This only works if
It's factorable.
it's factorable. There's plenty that aren't. That one's not factorable.
Yeah.
What two numbers multiplied -4 that add to +2?
-1 and 2. No. Nothing.
Nothing. Right. So nothing. You can't factor that one.
So
There's
you
this
do-
technique. It's called completing the square. I won't bore you with it, but it looks something like this. I won't explain what I'm doing here, but it's called completing the square, right? And completing the square works all the time. Factoring only works sometimes, but completing the square works every time. The issue with completing the square is no one remembers how to do it, and it's a little bit challenging. It's not impossible. And the reason why no one remembers this is because there's a way to use completing the square that gets you to the quadratic formula. And the quadratic formula is easy to use, and it never changes, and it always works. So it's technically where the quadratic formula comes from. I'll show you in Algebra 2, or Miss Newburn will. But no one uses complete the square. It's very rarely used. We will use it occasionally. And like I said, it happens the same thing. The teacher says, hey, we're going to solve this by completing the square. No one remembers how to do it. Okay? But everyone will remember quadratic formula and factoring. Okay? So the other method that works, and it comes from completing the square, I can't teach it to you, unfortunately, right now, is called the...
Quadratic formula.
So step number 1 is your quadratic must be in this form. And if it is in this form, then you get...
-b plus or minus the square root of a minus b plus square. The quadratic formula. Over ac squared. Something like that.
You're close.
-b plus or minus the square root of b squared plus ac. 2ac. Over 2ac. Something like that.
There it is.
4ac.
All right. So I used to, at least in junior year, when I had juniors taking this, I showed them all the people who've gotten tattoos of this thing. I'm not joking. There's people that get tattoos of this thing. It's so, I don't want to say it's important, but it makes your life a whole lot easier. You don't need to remember factor. You don't even have to try to factor. You just got to remember this silly formula right here, and it works every time to solve for a quadratic.
I still think it's impressive that I got pretty close, seeing as how we did that a long
Agreed.
time ago.
So what we're going to do tonight, even though it says some of them to solve by factoring, I believe, we're going to solve them all by quadratic formula, because you guys probably don't remember how to factor. So we're going to solve every one tonight by using that formula, so if you don't have it written down. It's in the book as well, too, on the page that I show you. Write it down. Okay? All right. So this is your standard plug and chug. I mean, give somebody, it's science class. Give somebody a formula and just say, do it.
But,
Right?
but you could get possible answers because of the square root.
Well,
That
just
leads to
remember,
imaginary numbers.
not all quadratics actually touch the x-axis.
Yeah.
So, for instance,
So you could,
if the quadratic is concave up and it's above the x-axis, no solution.
and sometimes there's only one solution too.
And
So
this
it could
was,
go like
I
this.
want to say, literally one of the last classes we did during last year COVID, and this was called the discriminant. The discriminant is the inside here, b squared minus 4ac. And if you ever do b squared minus 4ac and you get a negative number, no solutions. And that would
Well,
be
there
the
is a
shapes that looks
solution.
like that.
There is a solution because you can just use a plus bi.
No. No solution in the real number system.
Well, right.
Okay.
I mean, but you
All right,
can
we will
still
wait
use-
for that for pre-calculus. All right, but yeah, and this is the same parabola. These are two different parabolas. If it's concave down and it's below the x-axis, it never crosses. No solutions. You're going to get the square root of, I don't know, -39 or something like that. It could also be concave up and be above The other two possibilities are that the parabola only touches it at one spot. And what happens here is that b squared minus 4ac will be equal to 0. And so therefore it doesn't matter if it's plus or minus, there's just 0. And then the last one, the more common one, is when it touches in two different spots. I believe I've given you ones today that they all touch in two spots. Okay, so let's do a couple. All right, I'll do a first one and then you guys will do a couple.
I don't think we got
It's at the end. All right, so here we go. Step number 1 is to make sure that the quadratic they give you is in standard form. And I'm not saying you literally have to write it above it, but you certainly got to think about it. So once it's written above it or you're thinking about it, step number 2 is you got to tell me what A is, B is, and C is. McKinley, what's A, B, C?
1x squared is
We're looking just numbers.
x squared.
Give me A.
A is 1.
B.
1 is 7.
C.
12.
Okay. Now, be careful if one of them is negative, you include the negative sign. So for me, I write A, B, C. Some people don't do that. And then we're just going to rewrite the entire equation, one piece at a time, and plug in the numbers. Anna, go left or right?
-7.
Well, we'll start with x equals.
X equals -7 plus or minus the square root
There's a big long square root symbol.
of 7 squared
Okay.
minus 4 times 1 times 12.
So when you do this for real, a lot of times kids will, if there's a 1 there, they just leave off the 1 because it doesn't change anything. Right? Keep talking.
All over 2 times 1.
And you'll, after you do about 2 of these, then what you do is you automatically do that multiplication immediately. You don't do any of this stuff up here, but you'll immediately look at 2 times A is, and you just write the answer. But we'll start off, we'll write it the way it's supposed to. Okay? You understand what I mean by most people don't write 2 times 1, they just write 2. Okay? And it won't be always 1. I mean, it could be 2 times 4. Then we do the math using PEMDAS. So, Allie, what are we going to do first? Not, well, what's underneath the square root we're going to do first. So what do you get? So what do you get? Don't overthink this, just do it. No. Tell me what you're thinking. What are you supposed to, what do you think you're supposed to be doing right now?
Do 7 times.
Okay. You're having a brain fart if you can't think of that one.
49.
49. Keep talking.
And then you do 4 times 1, which is 4, and then 4 times 12,
Which is?
which is 48.
How could you do that and not do 7 squared? I don't know either. All right. Keep going. Now what?
And then you do 49 minus 48, which is 1.
Okay.
Square root of 1.
Square root of 1 is?
1.
All right, I write on space. So here comes the only tricky part you got to remember. It's not that tricky. Is that this plus or minus means 2 separate equations. One where it's plus 1 and one where it's. So I'm going to write those 2 equations, and it doesn't matter which one you write first.
So negative 8. So it's going to be -4, -2. Yeah, negative 4.
Okay.
We can figure that out.
By the way, this one is factorable. What 2 numbers multiplied 12 to add up to 7?
6 and 2. 4.
3 and 4. So when you do the zero product property, you get -4, -3.
Yeah, that's pretty much it.
And I kept it nice and friendly. So did they do it in the homework. They mainly gave you factorable ones. But I'm just going to say, you know, we're less than a year away from you learning this, and you've already forgotten how to factor. You're not going to forget how to do the quadratic formula. So even though you're going to see this now, we're not going to see this again. We might do a quick review before PSAT, but you're going to have quadratic formula on the PSAT test. But it's an easy thing to remember. The only thing you got to remember is it's got to equal 0. And if it doesn't, you force it. All right. Let's do this one. Write this one down. By the way, this was the ugly. Do you remember how we factored this?
We would do -3 and negatives together.
This is one of those ones where A doesn't equal 1.
Oh,
This
right.
is the hard one. You know what I mean? We're less than a year since I taught you this, and you all were good at this, and you've already forgotten it. You're not going to forget the quadratic formula. So when you're ever trying to solve a quadratic and you're not 100% sure how to factor, use quadratic formula. All right. Jack, give me ABC.
ABC is 2, 3, 5.
Nope.
Negative 2, 3, negative 5.
Nope.
2, 3, and negative 5.
Yes.
That's what I
You didn't
said.
know you didn't.
I said 2,
You
3.
said -2, 3, -5.
No, I said 2, 3, negative 5.
Do you want me to hit the record button?
Yes, I did.
All right.
I said 2, 3, negative
I'll
5.
play it at the end of class. All right. Here we go. You okay?
Yeah.
McKinley, left or right? Give me the whole thing.
3 plus or minus 3 squared minus 4.
Wait. What's that saying?
Negative 3, sorry.
-3
Plus or minus square root 3 squared minus 4 times 2 times 5 over 4, or 2 times 2. Next time I'll actually get it. Yay.
All right.
Okay.
Anna, what now?
2, 3 squared,
Which is?
9.
Ben, if you're not going to let us in on the joke, we don't want you laughing. Keep going.
Then you do 4 times 2, negative 4. And 8. And then 8 times negative 5. 40.
You agree?
Positive 40 because of the negative.
Yeah. You got to be careful with those negatives.
I hate
All over.
4.
Keep talking.
Then you do 9 plus 40, which is 49. And then you do the square root of 49, which is 7. And then you write them into 2 different equations.
Which are?
X equals -3 plus 7 over 4, and x equals -3 minus 7.
Okay.
And then you just solve them.
Okay, so -3 minus 7 is
Negative.
-10 over 4 would reduce to,
Well, you don't need to reduce this stuff.
yeah, you do.
-5.
-5 over 2.
Oh, okay.
And the other one gives us,
4 over 4, which is 4.
which is 1. Okay? So -5 over 2 and 1. You don't need to change it to a decimal. Okay.
What if I want to change it to that?
You can. There's nothing wrong with that. But
So now that we.
and this one was not factorable. Not factorable.
Well, it could kind of. You just have to work around it.
Technically, anything's factorable because then you can just use decimals.
Well, we define factorable as being an integer, coefficients and constants for the binomials.
But everything could be worked around in math. Didn't you say that math can be worked around and make everything? Or is that?
I've said in algebra that you can literally do the wrong thing as long as you do it to both sides.
Yep. And then you get to the right thing.
And that you just create yourself more work, but it will work. All right. Al, you're up. ABC.
That's factorable.
What's the factor?
-4 and 2.
Yep. So what do you think the answer should be?
So then it's going to be 4 and -2.
Well, let's see if he's right. All right, keep going, Al.
So it'd be x equals -2, so +2.
Okay.
Plus or minus square root of -2 minus
-2 squared.
-2 squared minus 4 times 1 times over 2 times 1.
And like I said, a lot of kids will immediately square, and they'll immediately do the 2 times a. And she already told me that a -2 is a positive. You do that as well too. Okay. So -2 squared is, and that would give us
Negative.
Positive 2.
therefore we get
34,
36.
36, something.
therefore we get
4. No. 6. 6.
Sorry.
what?
I'm thinking of cubes. I'm sorry,
4.
but cube of 4 is 68.
12.
Never mind.
Yeah.
Therefore we get
8 over 2 and
No, -4 over 2 and 8 over 2.
no,
no, he was right. 8 over 2 and
yes,
what else?
and -8 over.
No, you got that one wrong.
Well, I got it close.
You got one of them.
It
So you do get -8 over 2. What's the other one you get?
No, you don't get -8 over 2. You get.
I'm sorry, +8 over 2.
Oh, that's a point.
Yeah, that is a point.
That's a cheap point.
That's also 2 points from you.
He said
You
he
never wrote down
said
that first point
he
today.
said the right thing, and I agreed with him, and I said it backwards. That's not even fair.
Yeah,
Yes,
that's fair.
that's fair.
I caught you in your
So
own way.
8 over 2 and
Negative
negative
4,
over,
2,
which is
the 6, the 2.
Negative 2.
You're confusing.
all right. And we already knew those were the answers. Okay. Cool. So when does this get hard?
When the numbers get really big.
They could. That could certainly make it more challenging if the numbers are really big. I do want you to remember that if b squared minus 4ac is negative, the whole thing's negative. And what typically happens is you'll drop a negative and you'll think you get a negative when in fact you've dropped a negative. Now you can get a negative. It just means that it's one of those parabolas that doesn't touch the x-axis. So there's no solutions. But generally speaking, it only gets more challenging when there's negatives involved or the weird ones. Why is this one weird?
Oh, it doesn't have
Because it doesn't. It does have
Well,
a
it does
C,
have a
but-
C.
But it's on the other side.
So you need to do algebra first. So what's the equation?
21 plus 1 with all the same
Dude,
numbers.
that's factorable.
What?
21 plus 1.
That's factorable.
What?
21 plus 1.
We need to get it in the form of ax squared plus bx
Yeah,
plus
but you
c.
do 21 plus 1, then you subtract it, then you technically get that, but you can skip all that and do x2 minus 4x plus 1. I am right.
How about we subtract 21 from both sides?
Oh, yeah, that works.
And what would we get?
Fun.
You would get x squared minus 4x plus 3.
Minus 21. All right, I got my point
Okay,
back.
there we go.
But
No,
I
no, no,
still
no.
got
No, you
it.
didn't get your point back. That's not how it works.
You got it wrong.
Okay, but I do know what the answer is to this.
What's it factorable to?
It's factorable to
Negative 8.
negative 7 and 3.
Well, we wouldn't say it's factorable to that. We would say it's the binomials would be x minus 7, x.
X plus 3
So the answer, though,
is 7 and negative 3.
yeah, that's what we would say. Okay. But if we use the quadratic formula, a is 1, b is negative 4, c is negative 20. It's big numbers, right? When you multiply 4 times a times c, you're multiplying 4 times 21. So you're going to get a larger number, but don't panic. Let's see, that's going to give me 16. That's going to give me a positive what? 84?
Yep.
What's 16 and 84?
Is 100.
Yeah, that's a math teacher question right there. You get 100, right?
Which is 10.
Which
so-
is 10. So can you do that one in your head real quick?
Yep, 14 and 6. So then you get 7.
14 and what?
6.
Negative 6.
Negative 6. A number.
So therefore you get
So then you get negative 3 and
Positive.
positive 7, which we already said was the answer. Okay.
Boom, I'm right. I get to go.
All right. McKinley, you get to go home if you can tell me on the first one what A, B, and C are.
Just X and 2.
Okay, so I need an A, a B, and a C. A, B, C. What's A?
50 X squared.
It's never
X
includes.
squared, just X squared.
It
50,
never
50.
includes. 50, okay. What's B?
1,
What's C?
2.
You guys agree or disagree?
disagree.
What
B is
one are you
0.
disagreeing on?
B is 0.
Why is B 0?
Why would be 0?
Because if B is 1, then it would be 1x, and it would just be an x there. If B is 0,
Yeah,
then
but
0
there has to
times
be
x,
an
so it's
x
50x
Well, where's the X?
Well, you can add an X.
plus 0x.
Turns out that this is just a really skinny quadratic that's moved up 2 from the origin. So when you're missing that middle term, it's not shifted left or right. It's just shifted up and down. Remember, we covered this briefly. The first one tells you how skinny or how wide it is. The last term tells you how far up or down it is. And the middle term is going to show you, in general terms, how far left and right it is. That's in very general terms. All right. It's actually an interaction between the three things, but that's in general. Okay, McKinley, recover and tell me A, B, and C for the last one.
That's 3, 3, 4.
You agree?
No.
I got 2 yeses and 1 no.
I agree.
It's negative.
Oh, yeah, it's negative 4.
Oh, yeah.
Oh, so be careful when it's not in standard form. All right,
I knew that.
questions? All right, homework. Now it's going to tell you, if somebody open up the book, it's going to tell you that if it's factorable, I just know that that was a bridge too far, that we're just going to solve the quadratic. 163. So some of them are factorable. It says solve each by factoring or by using the quadratic formula. Just use the quadratic formula. If you are solid on your factoring, which I don't think any of you
I
are,
can
or
factor.
well, what if a doesn't equal 1?
I can't remember how to do
So
that.
give
Let
me
look that up. I
one.
need not for book.
You're gonna need an algebra. Give me one where a doesn't equal 1. I'll show you quick.
I don't know one that's okay. Wait.
One of the first couple ones. are gonna
Okay.
be factorable.
2z squared plus 7z equals 0.
And that one's not factorable.
Okay. How about 15 plus 4y squared equals 17y?
4y squared. What's the middle term?
Negative 15. No, not wait. I lost my. No, negative 17y.
And then
And then 15.
plus 15.
Yep.
All right. So a times c.
60.
Now give me the factors of 60 to add to negative 17.
Oh, okay. 1 second.
Man, I want to be an honor.
If it's factorable, this will work. If it's not factorable, then this doesn't work.
Well, it's factorable because.
Well, let's see. It's 1 in 60, 2 in 30, 3 in 20. It's going to be this one.
3 and 20.
So
And it's positive though, so
it's positive. So negative. That didn't work.
It's not positive. Okay.
Well, there might. I don't know. Don't give up now. 4 in 15.
No.
Does 8 go into 60? No. Does 10? Yeah. 10 and 6. Oh, that's close. 12 goes into 60. 12 and 5. 12 and 5.
Oh yeah.
And that would have to be negative, negative. Right?
So then, yeah.
So we rewrite this 4y squared. We write minus 12y minus 5y, because that would add up to negative 17. No, plus 15. So all I did was rewrite it. And you remember this? It went
And then you put
parentheses, 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 parentheses. Factor.
Then we get
Pull out a
4.
4y.
So we get the 4y times y minus 3.
Yep. Now when the first one is negative, we're going to pull out negative.
So then we get negative 5.
And we're going to pull out negative 5. And the magic is it's going to be this.
Y plus 3.
Okay. And then we write this and this. So we get 4y minus 5 and y plus 3. And then we do zero product property. So this was easy. It's going to be negative 3. It's a little bit hard to do. Add 5, divide by 4.
So then we get
5 over 4 and negative 3. I wrote them backwards, but those are the best. I'll just say, it's easier to do quadratic formula. It's quicker.
It's easier to do it when there's just.
And then the other thing too is you've got to remember this. I'm the math teacher, so I'm going to remember this, but you probably aren't going to remember this. It's just not, the normal factoring where a is 1, everybody can remember that by even through calculus. But this, most people forget because everybody just says quadratic, I'm going to use quadratic formula. And no one remembers complete the square.
I don't even know how to do that.
I know, I didn't teach it to you. I should have, right? If we would have not started late and ended early. I shouldn't say that. If we'd started on time and we didn't switch to 3 classes a week, I would have had time to teach you that, but I didn't. All right, Ben, you have any questions?
No.
What was the joke about earlier?
What joke?
The one that you were laughing about.
When was I laughing?
We heard you laughing multiple times.
At the very beginning?
Yeah.
Oh, I was talking with my sister.
Okay. All right, any questions?
No.
All right, we'll catch you later then.
Goodbye. Have a nice day.
You as well.